Hello, everybody. Welcome to our live stream today. This live stream is about the latest geospatial data type in Apache Iceberg and also Apache Parquet. And today we're going to talk about how we're going to support geospatial tables in the open lakehouse architectures, right? This means lots of new opportunities, of course, new challenges as well to our geospatial industry. So today it is my pleasure to have several very awesome speakers in the same room with us and share about their understanding about this geodata types in Iceberg and how that will impact the overall industry, right? So now let's do a quick round introduction, right? And so let's start from Chris. Please say hi
Hey,
to the audience.
everybody. Chris Holmes. Main gig is Planet Labs. I do lots of different product partnership strategy stuff there. And then have kind of lots of different community hats. Help start the GeoParquet project and usher that along. Yeah, did stack stuff before that. And then, yeah, I have another side thing with Taylor Geospatial Engine and kind of working on Earth observation and AI for global data sets. So that's me.
Awesome. Thank you, Chris. Sihong, please.
Hey guys, I'm Sihan. Sorry, I'm kind of recovering from a cold, so my voice is not great. Sorry about that. But yeah, I'm right now working in Databricks. I work on the Spark team. But I just joined. Previous to that, I was at Apple, where I worked on Apache Iceberg. I'm an Iceberg PMC. That's where I got to know Ja really well. We worked together on the geospec for Iceberg, and that was a multi-year project. Yeah, and then before that, I was at Criteo, and before that, I was at Cloudera. I'm also Hive PMC. I was working at Apache Hive back in the day as well. Yeah.
Awesome. Thank you. Vikram, please.
Hi, I'm Vikram, CTO of Foursquare, leading the transition of our company from consumer app company into a geospatial platform. We have several offerings in the geospatial space, most notably our Places dataset, which is now open source. We also support the Kepler GL open source project, and we have several products built on top of that. Among other things, we also have our core assets are places and an understanding of how people's behavior around places. And we have an ad stack that helps companies measure the effectiveness of of their campaigns on foot traffic and sales. Prior to Foursquare, I was with Amazon for about 15 years. I was the founding engineer on Amazon Alexa, worked there for 10 years on different pieces of that stack.
Awesome. Thank you, guys. I saw there's a question from chat asking if the session is being recorded. Yes. So this webinar is being recorded, and after the live stream, so we're gonna share the recording with you guys. And also during the webinar, whenever you have questions, please feel free to put that in the chat, and we're gonna pick up questions from the chat and ask the audience, and at the end ask the panelist, and at the end of the live stream, so we're gonna have quite some time for Q&A. So please feel free at the time to raise your hand, and we will allow you to speak, and you can ask questions to the speakers. All right. So as you guys already know, so in February 2025, so which is a few months back, so we introduced the geodata tab into Iceberg as well as Parquet. So this geodata tab is a big thing. It is an effort that we started about a year ago, and that actually went through lots of discussion in the communities and went through back and forth, lots of things going on behind the thing. Although probably to you guys, it is just like a news saying that so there are new data types in Parquet and Iceberg, but there are lots of things going on. And today we're going to talk about so what was actually introduced into this Iceberg geodata type and why we designed that way and and how it started in the first place, right? So now let me ask some questions to Chris. So Chris, so I think all the Iceberg geotypes, Parquet geotypes, they all started from this project called GeoParquet, right? It is an effort started by the community a couple years back. Can you talk a little bit more about the GeoParquet project and let us know. So what is GeoParquet and how you decided to start this project?
Yeah, so GeoParquet, I mean, I think probably most people know Parquet, probably GeoParquet, but the idea is Parquet is a super powerful format that has a whole bunch of uptake throughout the broader data world, but it didn't understand geospatial. Lots of people put geospatial data in there, but there was no interoperability. Somebody putting their spatial data in one would make some choices. Often the similar choices, but not exactly the same, and other people would put their data in and make other choices. So the idea was just let's standardize that. And Parquet has a nice kind of system to put in metadata so we could use it pretty easily without trying to hack into things at the core. In terms of how it started, there were kind of two little mini efforts that joined. One was sort of within OGC, Javi de la Torre from Cardo kind of pushed this effort to get OGC a bit more relevant with cloud data warehouses. And he had spent a bunch of time working with BigQuery, Snowflake, Redshift, and Cardos kind of positions themselves then. But it was a huge pain to take geospatial data out of one and into another. So like they all support geospatial data quite well, but they all support CSV, JSON. CSV for geospatial isn't great. JSON, there's GeoJSON, but they're all making sort of different choices because what they want to do with spherical edges and doesn't quite fit into GeoJSON. So initially he wanted to just pass that between in JSON, but then I was kind of looking and saw they all supported Parquet. I didn't know Parquet, but was kind of crazy that they all supported CSV, JSON, and Parquet. So I started exploring, hey, what if we just do a geospatial type? And then Tom Augsburger from Planetary Computer kind of saw that effort and connected with the GeoArrow community who had actually implemented a GeoParquet and a GeoArrow in R and GeoPandas. And so we sort of combined forces and said, hey, let's do this, iterate, kind of get all the details right, and sort of go from there. So yeah, the core initial thing was just interoperability between cloud data warehouses, but we always sort of aspired for, hey, uh, could you do a streaming format, a format initially we were thinking GeoParquet, but that's why the Iceberg stuff is so awesome because it really is that where you don't have to, like GeoParquet, you can pass data between these, but you're passing data import export, whereas Iceberg really opens up this possibility of, hey, just store it on the cloud and use it natively within these systems. So
Great, great. So if possible, can you give us some takeaway about how GeoParquet better than other file format like GeoJSON, CSV, right?
yeah, so I mean, so GeoJSON is an amazing format for passing stuff through the web and through a web API. If you want to do a ton of data in GeoJSON and kind of pass it around, it doesn't have an index and it gets pretty bulky. So a lot of it is just, what you're kind of using it for. In GeoParquet, similar to, Parquet versus CSV, is just a much more compact, fast, robust, compatible format. I think in the geospatial pace, it sort of competes more directly with, shapefile, which people still use, but has a whole bunch of problems of you can't have a column more than 10 characters, it can't be more than 2 GB. GeoPackage was a next iteration, which is based on SQLite, super solid, but I think they sort of do too much. There's all these different things that you can do with it, and the cloud data warehouses, the mainstream data world is never going to read a geopackage, whereas they will read a Parquet file. So that's really its sweet spot, especially right now, is just that interoperability with all those mainstream data tools. I mean, we need to teach them geo, but we don't have to say, hey, support this crazy new format and add, BigQuery, JSON, like GeoJSON or JSON CSV and GeoPackage. Like everybody in the main world would be like, what's that? So and then the cool thing is just like there's the Parquet format's just great. Like it is so small, so fast. Like I was sort of blown away when I first started trying out and testing it of how well it performs, as it is about the size of a zip shape file, but you don't have to unzip it. And then has also really good structs and nesting and ability to represent these much more complex data structures that people want to put stuff in, which was never most geospatial formats don't do that. So yeah, I've loved working with it. Yeah, it's just super awesome. So
Awesome. Yeah, definitely. I do agree that it is time to end the data silos for geospatial data. We should be, embracing the mainstream world, right? Cool. Now let's talk a little bit about Iceberg, right? So Zihong, I got some question for you. So can you tell us a little bit more about the geotypes in Iceberg? So what this is about, and how do you feel about that?
Um, Yeah, my feeling, I really like it. I think uh so Iceberg, for a long time, well, it's a little bit back, like, I started Iceberg, I was thinking it's really cool technology, like it can do asset transactions. I was just interested in that. And then at some point, there was kind of I think Ryan Blue put it like he said it's kind of like a revolution in the data industry. Like Iceberg was breaking open data silos, right? Like people not only open source projects, right? And initially we contributed, Spark support and Flink support, but so many open source projects themselves started building Iceberg support, which was great. But I think Chris also alluded like proprietary systems like BigQuery and Snowflake, they started opening up to Iceberg, and that was just amazing. There was such a pent-up demand for a cloud native asset-based table format that I think we didn't really see coming. And so I think having Geo in Iceberg, that's really kind of spreading that iceberg moment to the Geo as well. I think Geo World, as you mentioned, kind of lacked a standard before GeoParquet. And then with GeoParquet, they lack kind of interops, and now Iceberg provides all that. So I'm really glad this is happening. I think for both fronts actually, like I think from Iceberg point of view, it's great that users now don't have to have a separate system for geodata. They could just store stuff in Iceberg itself. And I think for the geo users as well, it's really great now. Every Iceberg summit or every summit and every meetup, I'm always blown away like how much people are like how creatively they're using Iceberg. So if you have data in one place, there's so many systems and creative things you can build on top. That's really good. I don't know if that answers the question, but yeah.
Yeah, great, great. So yeah, I think everybody in our community is so excited about this geotyping Iceberg. Iceberg is, is probably the next big thing for the for the data industry, right? So actually, since we talked about this, can you give us like give us some ideas about how Iceberg is like what kind of additional features Iceberg is adding in addition to Parquet, and why you should embrace this kind of lakehouse architecture instead of this kind of proprietary table format in whatever lakehouse, whatever old world data warehouse you're using.
Yeah, sure. I mean, I can go on like for a long time, but I'll try to keep it
For
kind of.
sure.
But yeah, I think there was three main buckets I was thinking of. First is the functionality, right? If you just have like, files on a disk, if you have a very simple use case, like forever you're just writing the same schema, reading the same schema year in, year out, I think you'll be fine. But the minute you have some more complex use cases, you definitely need a table format to keep track of that. For example, if you have a schema change, if you have like an incompatible schema change, on paper, yeah, there's some rules you can work around, but yeah, you really need a system at the end to not to mess up like Iceberg, right? It tracks like schemas for every file so that when you query, it knows which schema to use for every file. That's great. And then aside from that, it also has a lot of procedures that you can obviously write yourself, right? Procedures for re-optimizing your data, right? Using a different partitioning scheme for clustering, for sorting, for we're going to build space filling curves. I mean, you can always do that yourself, but Iceberg provides a lot of functionality. So I think that's the first step. I think second step is, or second category, I would say, is performance, right? So, the file-based systems that Iceberg was replacing, they're not cloud native, right? Cloud, you cannot really list directories efficiently and consistently. I think that's actually one of the main motivations for Iceberg. Iceberg always tries to avoid file listings where everywhere, like it doesn't use file listings at all. That was one of the main design philosophies, and having all the listings and metadata files. So it's very efficient to find all your files. And on top of that, we don't have to open every file. So imagine if you had a folder with like a million files, you would have to open up every single GeoParquet file to find out whether the data is there or not. Iceberg has such rich metadata that we can actually prune out files without even opening them. So that's a great benefit. So I think second bucket is performance. And then the third bucket, I think the main thing why people should use Iceberg over traditional systems is ACID transactions. And I think that's really why like a lot of systems started using it, like, BigQuery, Snowflake, AWS Redshift, in addition to open source projects. I think there's many now use cases that, where ACID is necessary. For example, privacy, right? Like I think when I started Iceberg, I was interested mostly from that point of view. If you know GDPR and European Union, if you do business in EU, the user has a right to be forgotten, and you have to remove user data within, X number of days of the request. And that's really hard problem for big data world, right? Like how do you do that across like thousands of partitions without stopping the world? And so Iceberg from the ground up was designed for, like highly concurrent kind of like workloads that doing all this modifications in an ACID safe way. All the transactions are ACID, so you can do a retention, or we call this like privacy jobs. You can do, re-optimize your files. You can do compaction. You can do, backfilling and stuff like that, all concurrently. And I think that's really hard to do if you just have files on disk or some other system. So those are the three big things. I think functionality, performance, and then just ACID transactions. If I have to sum it up, like for Iceberg.
Yeah, that's a great answer. I think Iceberg is the next revolutionary things to the data industry. And folks, if you are listening in, so I would strongly recommend you go check out what Iceberg is and how you can leverage that in your existing warehouse kind of workload. And if you're still using some sort of like a vendor lock-in or proprietary format, you should definitely migrate to Iceberg right now. And as you know, we have the geo data type coming in. So if you're using if we want to use Iceberg to store geo data, you'll be able to do that really soon. So yes, since we talk about this, like Sehong, another question for you. So this proposal is this Iceberg geo proposal is a big proposal. It is not that long, but it actually introduced lots of new concepts, right? So can you tell us like what elements of the proposal did you debate the most, and what kind of solutions you eventually picked?
Yeah, I was actually a bit, I think in this panel, I'm probably like the least knowledgeable in the geospatial domain. So I think that's why it was a bit hard to ramp up. I think the geo proposal, some parts, I think, we were thinking a long time about it. And then like obviously Chris and GeoParquet community already paved a lot of the road for how to standardize geotypes. So initially we were thinking, oh, maybe it's not that hard, right? Like we were thinking, there's already standards. What is geodata, right? Like all that class hierarchy of OGC, lines, polygons, that's pretty standard. We don't need to debate that. How to serialize that, WKB, they already made a standard, so we don't have to debate that. I think bounding box, that was, a little bit, Iceberg needs statistics, so, we think a little bit about that. Bounding box, mostly it's okay. I think the only case that was kind of weird is the anti-meridian kind of edge case, like how to do a bounding box that crossed the meridian. But like aside from that, that's mostly okay. I think the part that debate was the funny thing about geodata is like the same what I was realized after some time is the same place on the earth can generate different geodatas depending on the system that you're using, and then conversely the same WKB can interpret it to be different places on the earth depending on the system you're using. And I think it was just like how to bridge that gap. That's something Iceberg community was never really like had this problem before, like different types don't have this problem, right? Integer types, string types, they don't have this issue. And just having enough metadata so that the writer can express how he generated the data, and then the reader can interpret that data correctly. That's like, I think that was really the debate. And it was something like I had to step out of the comfort zone a little bit because again, I'm not like a geo expert, and we have to dive in. And but it was really cool to see all these people from, yeah, like all these very geospatial professionals coming in and debating like what exactly metadata. I think again the GeoParquet project paved a lot of the road. They had like a lot of the metadata spec of how to specify, CRS and edge interpolation. But I think Iceberg, we wanted to keep it more compact because our types are serialized, right? We can't just put like all these into. So it was kind of like a tension a little bit between how to keep it simple, but then like have enough specifics. I think we did a pretty good job in the end. I mean, we're still having debates even today, right? Like whether should we allow this CRS, should we allow this edge interpolation? But I think the overall, I think we did, even though there's a lot of debates, I think, and very contentious debates, like, should we have pro-JSON? Should we have just spherical versus geometry, geography? But I think at the end, we decided to have, we kind of came to a system, we have two types, and then we allow two parameters currently, the CRS and then the edge interpolation. And I think with that, we have the tools to let people kind of specify what we want. Because as Iceberg, again, we're a table spec first. We're not trying to be opinionated about what you can store. Otherwise, what's the point? Like only you can use it, right? So we want to be as open as possible, but also in a compact way. So I think we did a good job there. But yeah, it definitely took a lot of time.
I mean, it did make me feel bad as like a geospatial community member, how complicated and how much, Iceberg PMC members had to get it around get their head around just obscure concepts that like we're still debating about. It's like this is why more people don't use geospatial. And I think that's one of the big benefits of Iceberg is you guys took the time to like kind of understand it and present a simplified view. It's just like we need that because we tend to be like, you could do this and this obscure use case. Yeah, I watched your thing where like the one guy was like, people will die like when the bombs are. I was like, dude, just like don't let's just when people come to Geo, let's tell them, hey, you start here, you do here, you do here. But yeah, instead Ryan Blue is getting his head around edge interpolation. It's just But I appreciated all the deep actually getting your head around it. It is deeper. You guys got deeper in geospatial than most people in geospatial actually get because we had to figure those things out. But
definitely appreciate your support through that. Yeah, I definitely remember that we're there's someone saying if you don't get the metadata right, people will die. That was kind of like I was a bit afraid of that, getting deeper in this. But yeah, I think it worked out. But definitely with all you guys' help. So thank you for that. Yeah.
Cool. Yes, thanks for the great answer. Now let's look into this here from like a different angle here. So Vikram, right? So can you tell us a little bit more about like first, what did Foursquare do before like when you deal with data on S3 on the cloud storage, right? And how do you see like Iceberg this kind of open format going to change the future from a consumer or user perspective?
So yeah, I'll give a little bit about my background because it helps in the context of things. I started my career as an engineer in Teradata and worked on some of the low-level database data organization stuff and all that. And then I switched to Amazon for 15 years and worked mostly on real-time API, SDK kind of systems. So never really gone deeper into the storage level stuff or the data warehouse level stuff. So when I first joined Foursquare, I was new to two things. One, I was new to geospatial, and this is just 3 years ago. I was new to geospatial, and I was new to big data. And some of the things that fascinated me about the big data, like the big data technologies, were like there was so many things that you had to understand, so many pieces that you had to connect for it to work. But one of the most fascinating things was the state of the art until very recently for efficient access of data on S3 is still some manually curated folder structure, right? Like you partition the data into folders. And especially in Foursquare, we get billions of impressions every day. We get billions of place data inputs every day. We get billions of GPS pings every day. And we process that through these massive pipelines. And then your partitioning structure, which is determined through these folder structures, is fixed, right? Like if you have to change, if you have to evolve your schema, you don't have many levers, right? Like that's one thing. The second thing, I think Shijan touched upon this, like GDPR, right? Like you have to we capture a lot of data from the users and we are very privacy compliant. When the users ask to be forgotten, we have to go back all the way through the history and delete all the records. We had to build some very custom tools to ensure that, hey, we are doing it in the most optimal way. We had our own implementation of Bloom filters and all those kinds of things to ensure that it's a massive investment. So if you take a step back and look at this, right, like why this is so exciting, in the past, when you have these data warehouses and all that, like all these traditional data warehouse, you have the data layer is abstracted from you. You create tables, it stores, you create indices, it stores information in a certain way so that the application developer doesn't have to care about those things, right? So what Iceberg and potentially Delta a little bit, but Iceberg more predominantly has done, or the open table formats generally have done, is that they've elevated the abstraction for application developers from dealing with files to dealing with tables, right? Like, I think that is a significant thing. Like, I don't have to worry about the folder structure. I can change the partitioning scheme when it changes. I don't have to worry about CRUD operations, right? Like, I don't have to think about like which files I have to edit. I think all of those are pretty significant. I mean, sometimes people in the data industry take for granted. I think there are only two big pieces of evolution, significant inflection points in data. One is like the Parquet format, which simplified a lot of things for efficient access on data. And then the second part is like the table formats, which elevated the abstraction for the application developers, right? Like, so that was those are pretty important things. And the other thing, so this is about the general data industry, right? Like in the data technologies and all that. Geospatial, like 3 years ago when I started looking into this, I was trying to figure out like, hey, what are the compute engines I have access to so that I can work with geospatial data? And there are very few. Like I think even if you take something like Snowflake, they started adding support for geofields and all that very recently. So the options were very limited, and the few vendors which supported these geospatial data types, either you are logged into their ecosystems or you have to load all your data into into that database for it to be working, and you're talking about massive amounts of data. What Iceberg and the geo standardization in Iceberg has done is like now compute engines, you don't have to be logged into compute engines. You can plug up, and this is generally for Iceberg and any compute engine. Like now Snowflake supports Iceberg natively without having to load. Um, but more and more compute engines are now supporting geotypes, and the standardization helps a lot, right? I mean, in our case, like I think there is one more technology trend when coupled with Iceberg that makes this even more compelling, which is DuckDB, right? Like now I can, for an ad hoc analysis that is centered in the geospatial world, you do analyses on specific regions at a time. Now, DuckDB coupled with something like an Iceberg format or a GeoParquet format can give you can do a lot just on your laptop without having to expend a lot of compute. I think that to me is a significant jump up uh, in terms of the data ecosystem and the geo support in the data ecosystem.
Awesome. Yeah, that's a great question. Sorry, great answer. So, Vikram, one more question for you, right? So I know Foursquare recently released this new data set called Place dataset, right? Lots of people love it and start to use it, right? So I kind of curious, right? So how is this kind of Parquet or Iceberg format help company like Foursquare to like to deliver better data or better products to your customers, right?
I think I think some of the problems I laid out earlier, right? Like, let's say we get billions of impressions from various customers, various publishing partners, advertising publishing partners every day. And earlier, some of these were coming in JSON formats. Some of these were coming in. I mean, to me, the fact that somebody uses JSON is today for big data processing is almost like a crime. And so what we did was like we built index on top of Iceberg with that data, which allows more flexible querying if you want to just get data impressions corresponding to a specific publisher or specific days. We can do all sorts of compaction to make it efficient for historical access. I think that's the optimization that gives like, I mean, we think about a lot about compute optimization, right? Like, but how you lay out your data on disk solves a lot of the compute costs. And because a lot of what you do, what we have trained the Spark developers or like data pipeline developers to do over time is, oh, read everything from the disk, then repartition it in the right way, and then just do apply for your job. There is some of it that you still need to do, but the read from the disk is often the bottleneck, right? Like, and then this takes away a lot of that. Like, and we've been able to optimize a lot of pipelines in that particular way.
Cool. Thank you. Another question, I want to bring this up is, so when is this actually coming? right? So Iceberg geodata tab is already out, but that's a proposal, right? That's a proposal that was merged a few months back, and it is merged into Iceberg V3 spec, right? But like we have lots of people asking, so when we can start to use Iceberg, this kind of native data type, right? So this is more like first we need to clarify this a little bit, right? So what is Iceberg format and what is Iceberg implementation, right? So I think maybe Sihong, you can give us some insights there, right?
Yeah, sure. So Iceberg is primarily a format specification, table format specification. And every time there's incompatible change, we bump the version. So that's why you may hear people talking about V1, V2, and Geo will come in V3. That's primarily so that, readers, when they see a new version, they'll know, oh, this is a table I don't understand. I need to upgrade. So it's primarily a format version. And every time we change the spec, there's a vote, and that's why it was exciting to pass the vote to get Geo into V3. The V3 itself is, I think I was talking to some of the Iceberg PMC this morning. I think the last one was this minor addition to the Geo spec that we just got in yesterday. So I think after that, the V3 very quickly should be finalized in a final vote. But yeah, so Iceberg primarily is a spec, but under obviously the spec, there's many implementations of the spec, right? So there's Java implementation, there's Rust implementation, Python implementation, PyIceberg, proprietary implementations, right? Snowflake, BigQuery. And so after the spec is adopted, people can implement, and also you can implement already while the spec is being developed because you have confidence that the spec won't change. And I think we see with the geotypes, we haven't really had to change a core part of the spec. We had to go back, to add a few clarifications as we work with Java with to do. But yeah, I think so. Already, I think Whereabots is already contributing like implementation, reference implementations, we call it, for the spec. And we're already doing some reviews. Some of that depends obviously on the Parquet release and things like that. I think there's like a Parquet has to. So this whole thing was actually two spec changes on the Parquet side and the Iceberg side. I think that's another detail I think we should also point out. We had to add the Parquet logical type in order for the whole story to kind of make sense, right? And so we wait for the Parquet release, then on the Iceberg side for implementation, then we can start working on the rewrite support. But I think, yeah, going back to your question, once the spec is approved, which I think should be quite soon, I don't know the exact date because open source date, it's always some community thing, and we have to wait for the community to all be comfortable with. But once that's approved, then people can start implementing. You don't have to use the reference implementation. You can, obviously have your own implementation. I think that's also very fine too.
Cool, that's great answer. So I also want to chime in a little bit, right? So since I'm from Whereabouts, right? So Whereabouts actually implement the latest spec of the Iceberg geotype inside our own cloud compute environment. So we call it Havasu right now. And so while other engines are picking up to implement the Iceberg geodata types, so folks who are listening in, so if you want to give it a try, so please feel free to log into the Whereabouts cloud account and try it out, right? You can perform lots of cool operations using the Iceberg geodata types, including, ASIC transactions, queries, filter pushdown, spatial filter pushdown, schema evolution, time travel, right? All this cool thing you can actually right now you can try that immediately on Whereabouts cloud. Cool. I think that's the question for speakers, right? But I have some open questions for you guys, right? So I think there one important thing about Iceberg that is avoid vendor lock-in, right? So in the past, when we use like a data warehouse, I guess the very first thing you do is like you're gonna load or copy the data into this data warehouse, and next day you find out, okay, so this data warehouse is not working. I'm not able to connect that data to other data warehouse, right? You have to always go through this data migration. So Can you guys talk a little bit about, so how do you feel about Iceberg when it tries to solve the try to solve the vendor lock-in problem?
Yeah, I could touch on it a bit. I mean, I think you started to hit on it with this revolution in data, and to me, the core of it really is this separation of compute from storage, And so before, every single database, every single system, like it had those were coupled. You had your query and you had your data storage, and it was PostGIS or BigQuery or Snowflake, and that's just what you were in. If you want to get your data out of it, you had to take it out because it was like a custom format. So like the fact that Iceberg makes it possible where you can just find the best query engine for your given job. I mean, I don't think we're on the cusp of that, but like it is really coming fast and the big guys have committed to it. But this has been sort of the way I've justified working with my Planet time on GeoParquet and a little bit on Iceberg, and I'm so excited about is, Planet, we're making satellite data, we're getting better and better at extracting insights from it, which get into vector shape. But previously we were thinking about, are we gonna, and our customers are in every cloud, in every environment, are we gonna distribute, like a push to Snowflake and a push to BigQuery and a push to every data warehouse? And like 3 years ago, the answer was yeah, like once we really get there, that's probably what we have to do. But this idea of just having one place where we could push the data in an Iceberg format and then, they can all read from it and we don't have to worry about that and they can join into their system, yeah, is sort of incredible. And even from the Planet perspective, we're big BigQuery users. And so just this, we do every once in a while evaluate different clouds, and this ability to just kind of like, oh, moving to another cloud isn't going to be transfer every data in, but it will be get into Iceberg and then see what those best options are. So yeah, it's really exciting this time in sort of data because yeah, it's just kind of unlocking and I think just has huge potential implications.
I think the standardization of the storage layer opens up the doors for a lot more things. Like right now, even if I have to get observability metrics on how people are using. So first thing is, like, as I said, like even with our Places open source data set, we had to replicate the copy in multiple platforms. We had to put it on S3 bucket. We had to put it on Snowflake. We had to put it on Hugging Face. And then we have to capture, we rely on what those platforms provide in terms of observability for us to understand who is accessing our data set, what are the access patterns and all that. Now, having this common storage layer opens the doors for more standards of like, hey, can I get more granular metrics on like which rows are accessed, which columns are accessed, how often they are accessed, and those kinds of things help the data providers. I think the data, I mean, this is one of my, as a wearing my business hat a bit, one of the gripes in the data ecosystem is it's very incentivized towards the consumer, not the producer. Producers lack visibility. They just give up all the control once somebody creates a copy of that data. And so Iceberg and potentially Polaris or the Iceberg REST catalog with some access controls and all that will open the door to give control back to the provider and give more visibility into that. Like, so that's what I'm really excited about, like this evolution in this space.
Yeah, I mean, that provider friendliness really resonates with the geospatial world. Like, there's a lot of these public data providers from countries, and they've stood up these big infrastructures to make their data available. But then you go to a municipality and they just don't have, a full-time staff to keep a server running and do pager duty and all of that. So they end up just not really sharing the data, or yeah, just sort of make it available. And I think this opens up this possibility of just drastically lowering the barrier to be a data provider, just put it on a bucket, maybe even get requester pays and you kind of just know like, hey, it's just going to cost this much and everybody can pull it, do with it. And it, yeah, kind of shifts it from that compute cost. Like you had to store an index and provide an index to everybody. And this, you can shift the compute cost to the people that are actually using it as opposed to this big burden to a provider to keep this thing up and running.
Yeah, I think this is all very good. I think definitely this whole thing was driven by by customers who want don't want lock-in, as you guys said, and it's really opening the playing field to providers and to put data out in the formats. I think that's all good. I think yeah, I think Chris had a good point though. I think like this is definitely the promise of Iceberg. We are, everyone's working towards that. There are a few things left, I think, to do. I think you touched on the catalog. I think that's the other point too. I think the Iceberg has a catalog spec that just came out. I think not that long ago, actually, like I think 1 or 2 years ago. And these things actually take a long time to get wide adoption through the industry. I think the industry is now trying to standardize on that because you also need a catalog part in order to know, where the Iceberg table is. And so, once all the pieces are there, and obviously all these, there's some tension as well. I think it's mostly customer based. Customers don't want lock-in. Also, as working in Apple or Foursquare, using this stuff, we don't want to be locked in. But I think from vendors, it's always a bit of a tension, right? I see like vendors always, they always started with their own proprietary formats, and now like it's like a question how they can kind of move towards Iceberg. So I think that also will take some time to play out itself. I think so. But I think I'm optimistic, obviously, being an Iceberg community that we'll get there eventually. Yeah.
Cool. Well, so we are getting lots of questions in the chat. So, yeah, so let me pick some of them from the chat. Okay, so this question from Stephen, very interesting. So as you guys already know, in Parquet or GeoParquet, right? So there is min-max statistics at the file level, and in Iceberg there is also this like a lower bound, upper bound, right? So these statistics are critical to performance, especially for future pushdown, right? So can you tell us a little bit more about this and why they could like benefit the performance, like this kind of min-max statistic, lower bound, upper bound?
Yeah, I think there's multiple min-max bounds. So at the Parquet level, obviously, we introduced Parquet statistics for row groups to have lower and upper bounds, and for Iceberg as well. I think so, Iceberg as a big data system, we definitely need we're not a traditional database because we don't have like indexes and things like that, right? Secondary indexes. So we definitely need to rely on some stuff for data pruning. Partitioning is a big one. Lower and upper bound, but I think partitioning is a topic for the Geo proposal that kind of got a little bit. I think there's definitely ideas how to do the partitioning, right? I think already did a lot, and folks have already did a lot of research on XZ2 and kind of like advanced geo-partitioning techniques, but a lot of them are a bit like kind of new, and I think so. The primary way I think right now is to do this kind of sorting and using lower and upper bounds and making sure every Parquet file and within every Parquet file every row group is kind of like has a narrow upper and lower bound, so you get maximum pruning of data when you do a predicate pushdown. So I think that's the primary mechanism right now for that.
I think Stefan's question was just like in Parquet, you have min-max statistics. Why can't I just make one huge ass file, and take advantage of those? Like, why do I have to split it up to like give like?
Got it. Yeah. Oh, I see. Sorry, I misunderstood the question. I think definitely it's for just parallelism and the fact that you don't want I mean one huge file is pretty hard to operate on if if you want to modify that file like you have to just either copy the whole file and again so it's just dividing into units of work. I think typically we want to have a well-sized files so that when you run jobs. Like some jobs, for instance, parallelism is directly dependent on the number of partition, number of files you have. So, you definitely want to get a good sizing. For example, storage partition join, right? You only have one task per partition group, and so that's depending on how many files you have. So you definitely don't want everything in one file, I think, unless you're on a one laptop setup and you know exactly what you're doing.
Yeah, I also want to chime in a little bit here. So, in the latest Iceberg Parquet native geo data types, in particular in Parquet, so this proposal actually since it is native data type, we also introduced native statistics for geospatial, meaning that you will be able to have more granular statistics in Parquet file. So in the past, when we used GeoParquet, so the bounding box statistic it at the file metadata level, meaning that you can either skip the entire Parquet file or you load the entire Parquet file, right? That's the only bounding box you have. But with the native bounding box statistic in Parquet geo tab, you actually can have bounding box statistic at the row group level in Parquet. So meaning that you can actually have, like you can skip by row group instead of this entire Parquet file. So I think that's another benefit of this native data type. Cool. Few other questions, very interesting. So I think this is for Zihong. So Zihong, since you are from Databricks, right? So and you also work on Iceberg, and Databricks is working on Delta Lake, right? So what do you see, like when Delta Lake is going to adopt GeoType, and what's the future like of Iceberg and Delta Lake?
Yeah, so I have to be careful here not to, misrepresent my employer. So I'll keep a more conservative answer here. I think, but yeah, honestly, I think like going into Databricks, I didn't know much about Delta Lake, and I started looking into it. Obviously, it's everywhere in Databricks. Again, this is the tension that I was talking about earlier, right? Like all the systems had their own format, and now like how to integrate with Iceberg. That's the big challenge for every company, not just Databricks, but obviously Databricks is one of them. I think Delta Lake also has some advantages. Even Ryan Blue in the last Iceberg Summit mentioned that like Delta Lake is really good from the name. It's really good at fast writes, right? Because every write is just writing a delta, what changed. It's not good for reads. As Iceberg, Iceberg always and on the other hand, Iceberg, every time the writes are a bit slow because it has to rewrite the metadata, materialize the whole metadata, but then the reads are a bit fast. And I think we're trying to figure out, how to combine to get the best of both worlds. And I think with the V3 spec, a lot of the stuff that we did was with not just Delta Lake, but with like Parquet in mind, right? Like we put the definition of the geotypes in Parquet so that like different communities can benefit. Iceberg, obviously. Delta Lake obviously will adopt that one. And anyone else who just uses Parquet, right, can also adopt that. Same for variant type is another type in V3. So I think over time, Databricks is trying to kind of like make the Delta and Iceberg communities kind of like not communities, but the formats be more interoperable. So that's people can get the benefit of both. I think that's the position. Yeah.
And for the Geo community, I mean, we're excited on Delta doing Geo. I think, yeah, some of you were there and we met and we were just like, strategically, Iceberg has the momentum. Let's sort it out here. And like Parquet was similar. Like there's ORC, there's Avro, but like, hey, this is the one with the most momentum. Let's get the types right. Let's have all the debates on what should be. So the other ones are kind of easier to just use that. And so, yeah, I think at some point, if Delta Lake community, if we all want it, we should do it. And I think that's from the Geo, we should have Geo well represented, especially with all these like granular little decisions that people debated. Like, let's just not redo them every time. Let's just have it be kind of a meta standard of this is how you want to represent Geo.
Great
Yeah.
point.
Yeah, I definitely agree. I think this will like give at least remote headache for data table users like Foursquare, right? So right now, I guess you want to always decide, okay, whether I want to use Iceberg, whether I want to use Delta Lake, right? So by the way, Vikram, so like what do you think about the adoption of Iceberg in Foursquare, and when do you plan to like adopt Iceberg when the new data type is out?
Just on the weighing in on the Delta versus Iceberg debate, I think we tried out both. One of the challenges with Delta is it's as a consumer, it's always difficult to understand what is open source versus what is locked within the constraints, what benefits you only get when you're using Databricks as the compute. So that ambiguity and some of the public articles won't help until you get deep down into the weeds of like, oh, this is only available in Databricks versus this is truly the open table format. So while we started with Delta on some projects, we have switched over to Iceberg for a majority of the new things because of the I think just how it is structured, how the open source project is also structured with multiple contributors into this. Even though Delta also has other contributors, it's significantly viewed as, from perception wise, it's viewed as a Databricks project. And in terms of adoption, like we have adopted Iceberg more widely within a lot of our data sets. I think we're looking forward to, we've also adopted GeoParquet in some of our workloads, our open source places data set, thanks to Chris. We expose it in GeoParquet format. There are a lot of workloads where having this geo data type will help in efficient processing of our data, where it is processing our pings. I mean, we do very interesting things in the ad domain where we have to understand what GPS pings are in the proximity, in the right direction of a billboard to see if somebody saw the ad or not. So those kinds of proximity-based things would hugely benefit from having the geotype and not having to process everything in the data set to understand the subset of locations we need to process. So there are a lot of use cases in our space which could benefit from this, and we are looking forward to testing those out.
Cool, cool. So I'm curious, so Vikram, so in Foursquare, right? So when you adopted Iceberg, has saved geospatial data in Iceberg, but we didn't have geotype before, right? So what kind of like how do you store that in Iceberg, and what kind of tricks you guys played, right?
I mean, we haven't. I mean, currently we are using mostly Parquet and GeoParquet wherever possible. But for the Iceberg adoption, we haven't gone into more of the geo. So we have some which are geospatial and some non-geospatial. We have adopted Iceberg predominantly. We had to build. I mean, one of the things I think now more of the platforms are supporting native tooling. Adopting Iceberg is also a little bit of work investment on your side. Like you have to have the maintenance processes, otherwise your data files will, means we have to do regular compactions and all that stuff. So you need to have good hygiene around what kind of partitioning things you're applying. You can change it, but I think still it's a learning curve. So we started with some of the non-geospatial workloads and we are starting to see some benefits from it. But I think as we transition into more of the geo workloads, I think some of those things will come into play in terms of what kind of geo optimizations we can apply. But we are looking forward to that.
Yeah, that does to me relate to that question about, what comes next to try to make the format of underlying data storage and table layer as relevant as possible for clients accessing geodata. And I mean, it's cool being in these formats, but there are more knobs to turn than I think certainly most normal geospatial users want. Like Parquet, you can pick your compression, which is super cool, but like, do most people want to pick their compression? No, they just want to use this thing. And yeah, do most people want to do table compaction on all, like, no. So I think that's one of the next things is just kind of get those best practices really established and start distributing data. Like I'm yeah, curious when the first places data or the first Overture data as an Iceberg table is offered and when a government data set is available as Iceberg or a satellite footprint is available as Iceberg. And I think once geospatial users can just start to use it, they don't need to know all the details behind it, but it works with a whole bunch more systems. I think is that next step is really just that ecosystem adoption and implementation and getting it sort of into all the tools and get it as easy and seamless as possible to read and write without having to fall off because I didn't pick a knob right.
I think one of the things I read about, like, and maybe Shazan can talk about that, like over here is I'm excited about the catalog standardization as well, because that pushes more of the metrics and stats and access patterns that can be accessible from there, which again reinforces a lot of the compute engines and provides more control back to the data providers. More standardization that happens on like, I think to me, it's almost like a building block at this point that we have, and then more of the standardization that happens, whether it is around observability, cataloging, gives more control to the data provider and gives more insight into like multiple query engines are now forced to, because of the momentum in the space, are now forced to adopt these standards. That means you can plug and play different providers. So it's all great for smaller companies. You don't have to lock into vendors and all that. Like, so that's why I'm looking forward to the roadmap as well and some of the things on the roadmap.
Yeah, it might be good for someone to explain catalog from that Iceberg standpoint. Like,
Yes,
I've been
so
fuzzy
that's the
about that
elephant in
too,
the
of
room.
like, what is that?
Yeah, I don't know if we have that much time. It's
Yeah,
kind of
fair.
it's how but yeah, catalog initially was just like Iceberg was kind of delegating some of the the commit logic to a separate system. So it made an interface for catalog. And initially, historically, people were using backing it with the Hive Metastore as a catalog because that was ACID compliant, like it's built on a database. Over time, the Hive Metastore, and that's why I think I was alluding to earlier, like it's gonna take a little bit of time. Hive Metastore has been there for I don't know, like I'm a Hive PMC, and it's been like many more years than I would like to know. But like yeah, these things have a lot of momentum, and now Iceberg REST catalog is the Iceberg first catalog. It's a more modern interface. You don't have to use Thrift if you remember having used Hive Metastore, and so this is great. And also, there's a lot of benefits too to having kind of like I think Vikram was mentioning. Now you can, we didn't even think about it before, but you can build things like governance, permissions, and things like that in the catalog. Um, but definitely I think that space is still developing because again like this does take a long time. I think the Iceberg community from the beginning decided, okay, we just have an abstraction for catalog, but we're not going to be in the business of like implementing the catalog and things like that and delegate because we want to focus on the table formats. And so there's other communities out there. Obviously Iceberg community is involved in the specification, but then there's other communities out there implementing catalogs. And I think really, if we can get that right, then the whole story will be complete, right? Because you need definitely both the table format and all this additional metadata, like catalog metadata for the end user to have a complete system.
Cool. All right, I think time's up, and I'm glad we have all the awesome speakers in the same room and talk about the upcoming Iceberg geodata tabs. And I would like to also thank all the audience who joined us in the call. And as I mentioned before, this call has been recorded, and we will share the recordings to people who have signed up on the event page. And again, thank you for attending the call, and yeah, see you in the future. Bye,
Sure.
guys.
Yeah.